Hi there. This is the check for understanding that you should be doing after you watch the video about what box plots are and how to make them. Hopefully, you've given this a good try on your own before watching this video. It really doesn't do you any good to learn anything by just watching somebody else do it. You need to try it on your own first and then learn what you've made a mistake on so you know what you don't know so that you can replace that with good knowledge. We learned about box plots that each one of these sections is 25%. This is 25%, so is this part right here, so is this part right here. So altogether, this is 75%. This little part in the middle, the interquartile range, that's just 50%. From the median to the minimum, that is also just 50%, because you know median means middle. This is 1 quartile, 2 quartiles, 3 quartiles. That's another 75%. And then just this little portion right here, which I think is what this is referring to, that's just 25%. Number 2 is asking us to draw a box plot with the following characteristics. 50% of the values are less than 30. This right here tells me what my median is. So less than 30, meaning that vertical line through the center of the box is going to be right there. And then I kind of have to figure out where the rest of the box is going to be. 25% of the values are above 45. That tells me what my upper quartile is. So 45 is up here. This is my median. This is my third quartile. 75% of the values are between 26 and 50. Well, 50 is higher than 45. So that tells me right there what my maximum value is. And then this part here is a quarter of the data values. This part here is a quarter of the data values. Then I get to my median. So 26 must be the first quartile. And then they tell us that the minimum value is 24. Thanks for that. So the data is really spread out in this quarter, but it's really close together in this quarter. Box plots can have all sorts of different looks to them, but they all have this box in the middle, they all have a vertical line for the median, and they all have horizontal lines that go out to the minimum and the maximum, unless they're displayed like this vertically. But most of the time they're horizontal. So for the above data set, what is the interquartile range? Well, 26 was our first quartile, and they told us that 45 was our third quartile. So the interquartile range is from 26 to 45. And the interquartile range tells you the middle 50%. Does the box plot tell you how many values are in the data set? Nope. Does the box plot tell you the average? No. Mean and median are not the same thing. Median means middle. Mean means average. Those are two completely different things. Sometimes they actually happen to be the same, but not very often. The following data tells the wait times in seconds for customers in a checkout line at the grocery store. Make a box plot of the data and answer the questions. When I make a box plot, the first thing, sorry for the interruption, sometimes real life happens. So the first thing I have to do if I want to make a box plot is I have to put these numbers in order from least to greatest. So I'm going to make a quick dot plot below the line, 0, 0, 5, 10. These go by 5s, so there's another one. 15, 12 would be about right there. 40, 60, 120, in seconds. So this person was waiting 120 seconds. 53, 54, 68, 95, 124, 110, 103, 75, 82, 70, 64. And then it's just good practice to count them up and make sure that it matches how many data points you had. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. What did I miss? Zero, zero, got both of those. 10, that's that one. 15, that's that one. 12 is that one. 40 is right there. 60 is right there. 120 is right there. 53, right there. 44, is that the one I missed? 44, right there. Okay, now that I've got them all, I can put them in order from least to greatest, which I'm going to do down here. 0, 0, this was 10, this was 12, and this was 15. So I did 0, 0, 10, 12, 15. Then there was 20, no, 30, 35, 40, so that was 40. After 40 came 44. And then 53 and 54. And then 60, 64. 68. 70 and 75. 82. And then 95, 103, 110, and 124. Let's make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. What did I miss? How did this happen? 124. This is 120. I did miss 120. See? Real life happens. The phone rings, the alarm goes off, you miss a number, you go back and correct it. In order to find the median, I have to find the middle number. I can count in from the sides and find the middle number that way, but because I know that there's 20 here, I just have to count up to the 10th one, and then 10 from this way, and I'll find the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So halfway between 60 and 64 is 62. That is my median. So 50, 55, 60, 62 would be about right there. Then I have to find the lower quartile, Q1. So there's 10 items here. Go 5 in each direction. 1, 2, 3, 4, 5. Oh my, what is halfway between 15 and 40? 27.5, I hope. About right there. And 5 this way. 1, 2, 3, 4, 5. This is Q3. Halfway in between 82 and 95. Add them up, divide by 2. 88.5. 80, 85, 88.5 would be about right there. That's my box. 27.5, 62, 88.5. My minimum value is 0. My maximum value is 124. Finish this statement. 25% of customers wait this much or less in the checkout line. Well, it's the or less, meaning it's got to be a certain number and then smaller than that. So I'm going to say 27.5 seconds or less in the checkout line. Is it fair to say that the usual wait time is less than 1 minute? Well, 1 minute is 60 seconds, which would be about right here. So ask yourself, is it fair to say that the usual wait time is less than 1 minute? Do you see these data points being on average less than 60 seconds? Well, average and median aren't the same thing. The middle value is there, but based on how these are spread out, you can make an argument either way. I would say yes. It seems like there's about half of them here, and they're all kind of equally spread out, although it's more spread out over here, and they're kind of more clustered here. Again, you can make an argument either way. However you state your evidence, you can support whether you think yes or no. Thank you for watching.